to make the denominator rational to avoid division by a decimal. Now the process of making the denominator rational is what we call rationalization of sets. So for instance, let's say you are given the expression 1 over the square root of a. Then we can rationalize this expression by multiplying top and bottom by the square root of a. So we have 1 over the square root of a, and then we multiply top and bottom by the square root of a. Now 1 times the square root of a is equal to square root of a, and then square root of a times square root of a is the square root of a squared. So we have root a divided by, now the square cancels the square root, so we have a. So we've been able to rationalize this expression 1 over the square root of a to get the square root of a divided by a. Now let's solve some examples. So for the first example, let's rationalize the expression 1 over the square root of 3. Now to do this, we are going to multiply top and bottom by the square root of 3, or the numerator and the denominator by the square root of 3. So this is equal to, we have 1 over the square root of 3 multiplied by the square root of 3 over the square root of 3. Now 1 times root 3 is root 3, and then root 3 times root 3 is root 3 squared. So we have root 3 divided by 3. So for the second example, we have 4 over root 7. Now let's do this together. So let's rewrite the expression 4 over root 7, and then we multiply top and bottom by root 7 and then root 7. So we have 4 times root 7, which is 4 root 7, and then we have root 7 times root 7, which is root 7 all squared. So we have 4 root 7 divided by 7. Now let's talk about conjugate sets. So now let's talk about conjugate sets. So given the expression a plus the square root of b, then the conjugate of this expression will be a minus the square root of b. Now the difference between the two is that if you are given this expression, to find the conjugate of it, then basically you are going to change the operation in between the two terms, so that a plus the square root of b has a conjugate a minus the square root of b. Now let's say you are given the expression square root of 2 minus the square root of 3. Then the conjugate of this expression is equal to the square root of 2 plus the square root of 3. If you are given the expression 2 root 5 plus 4 root 3, the conjugate of this expression is 2 root 5 minus 4 root 3. So having this in mind, let's solve some examples. So for the first example, we have 1 over the square root of 3 minus 1. Now how do we simplify this expression? Now to solve this expression, we need to multiply top and bottom by the conjugate of the denominator. Now the conjugate of root 3 minus 1 is root 3 plus 1. So we are going to multiply both the numerator and the denominator by root 3 plus 1. So now let's solve together. So we have 1 over root 3 minus 1 times root 3 plus 1 divided by root 3 plus 1. So we have 1 times root 3 plus 1. So that's going to give us root 3 plus 1. And then for the denominator, we pick one term and then multiply by root 3 plus 1. And then we pick the second term and also multiply by root 3 plus 1. So we have root 3 multiplying root 3 plus 1. And then we have negative 1 multiplying root 3 plus 1. So we have root 3 plus 1 as the numerator, and then let's simplify the denominator. So root 3 times root 3 is root 3 all squared, plus root 3 times 1 is root 3. And then we have negative 1 times root 3, which is negative root 3. And then we have negative 1 times 1. So that is negative 1. So here we have the square root of 3 plus 1 divided by, now root 3 squared is 3 because the square cancels the square root. So we have 3. And then the square root of 3 minus the square root of 3 is 0. And then we have negative 1. So we have 3 minus 1. Okay. So the square root of 3 plus 1 divided by 3 minus 1 is 2. So we have 2. So we can split this to have the square root of 3 divided by 2 plus 1 over 2. So this is the final answer. Now let's solve the second question. So for the second question, we are going to rationalize 4 over root 7 minus root 3. So as usual, we are going to multiply top and bottom by the conjugates of the denominator. Now the conjugate of root 7 minus root 3 is root 7 plus root 3. So now let's multiply top and bottom by root 7 plus root 3. So we have 4 divided by root 7 minus root 3 times root 7 plus root 3 divided by root 7 plus root 3. So let's multiply across. Now 4 times root 7 plus root 3 is 4 outside, and then we have root 7 plus root 3 inside the bracket. So here we also have root 7 multiplying the whole of what's in the bracket, that is root 7 plus root 3. And then we have negative root 3 multiplying root 7 plus root 3. So we still have 4 times root 7 plus root 3 all over. Now root 7 times root 7 is root 7 squared. So root 7 squared is equal to 7. So we have 7. And then here we have root 7 times root 3, that is root 21. And then here we have negative root 3 times root 7, which is negative root 21. And then we have negative times positive is negative. And then we have root 3 times root 3. Now root 3 squared is 3. So we have 3 here. So we still have 4 root 7 plus root 3 in the bracket divided by, now the square root of 21 minus square root of 21 is 0. So we have 7 minus 3. Now 7 minus 3 is 4. And then 4 cancels out 4. So we have the final answer to be root 7 plus root 3. That's very simple. Let's solve our third example. So for the third example, we are to express 4 plus root 5 divided by 3 minus 2 root 5 in the form of p plus q root 5, where p and q are rational numbers.